So I want to demonstrate how to use the normal distribution function using this example 5.34 in your textbook. Now, here it says, suppose that a company has determined that the distribution of customer demand is normal with a mean of 750 units per month and a standard deviation of 100 units per month. Now, based off of that information, it says the company would like to know the following, and we have three different probability problems related to this scenario. And it says, number one says, what is the probability that the demand will be at most 900 units? What is the probability that the demand will exceed 700 units? That's number two. Number three, what is the probability that the demand will be between 700 and 900 units? Now, what I want to do before I solve this is develop a chart that shows the normal distribution. So let me just go ahead and create that. Now I'm going to apply the empirical rule where I want to figure out what the values are that represent 99.7% of my distribution. So to do that, I'll go ahead and put 99.7%. I'm going to hit equal sign. I'm going to say mean minus 3 times the standard deviation. Now I'm going to do the same thing, but instead of minus, I want to say plus. So the mean plus 3 times the standard deviation. And I know that the distribution, or practically all of my data values in my distribution, are going to fall within 450 units per month to 1,050 units per month. Now, anything outside of that may be considered an outlier. I'm going to go ahead and say units as a random variable. I'm going to start my value at 400. I could start at 450 since I do have 450 to 1050, but I'll just go ahead and start at 400. And I'm going to increment that by 50. So I have 450, 500. I'm gonna go all the way down until I hit about 1100. So let me go ahead and do that. There. What I'm doing here, I would be able to compute, or I would be able to construct a chart based off of this scenario. So I'm going to say NORM.DIST, and then I'm going to fill in the parameters. So I have an X, which is the data point, the outcome, mean, we know that, the standard deviation, we know that, and then cumulative, it's whether you want the cumulative probability or just that exact outcome. And so it's binary, true or false. So let's go ahead and fill this in. I'll go ahead and select the mean and then do an absolute reference. Or before the mean, I need the data point, right? So let me select that outcome. And the mean is 750, do the absolute reference there. Then the standard deviation is 100, do the absolute reference there. And then I'll say false and hit enter. So this is a probability, and this is practically zero. If I were to format this and increase the decimal points, I'm going to go ahead and just drag this all the way down. Now, we know since we are dealing with a continuous random variable, there is going to be probabilities between these two intervals, between like 450 to 500. I'm just skipping them because I want to just create a chart off of this scenario. So I'm going to select what I just created here, and this is somewhat of a probability distribution that ranges from 400 to 1100 units per month and the probabilities for them. So if I go to insert, I'll go to recommended, and I can choose any of these. Let's go ahead and keep it on this scattered chart. I'm going to press OK. This is a chart that could be used as a reference as you're trying to determine the probabilities that are given here for problems 1, 2, and 3, if it helps you understand it a little bit better. Now, I'm going to increment this, the x-axis a little bit. I want to change the values it took. So let's go ahead and say, I'll do it at 100. So Okay, so I went ahead and just cleaned up the spreadsheet a little bit. So now that I have my visual, I can focus on problem number one, where it says, what is the probability that the demand will be at most 900 units? Well, I know that my 900 on the curve is right here, and this is a symmetrical curve. So if I draw a line right down the middle of this curve, I know anything to the left of this is 50%, anything to the right of it is 50%, because one of the properties is that in total, anything underneath this curve, the area equals to 1 in terms of decimal point, or 100%. So I'm interested in the probability that at most 900 units, so that means 900 units or less. So we're looking at the cumulative of 900 and anything to the left of it. So if we were to sum that up, we know it's going to be more than 50%. So I'll say equal sign NORM.DIST. I have to put in the value of interest, which in this case would be the 900, the mean, the standard deviation, and a cumulative true or false. So we're looking for a cumulative. We know we're going to say true here. So the x is going to be the probability of x that we're looking for. I'm going to say 900, and the mean is going to be 750, and that's shown here in the scenario, and then the standard deviation is 100, and I'm going to select true, and this would be the probability number one. Now, the continuous distribution type of problem is a little bit different. So if we were to have said something like, what is the probability that the demand will be something like less than 900 units, you'll still put the number 900 here. You wouldn't go for 899 because it's a continuous random variable, so there might be decimal points in between the 900 units and the 899, and we don't want to skip those. So it's a little bit different from discrete probability distributions, where we would account for that one value. If it said less than 900, we would say 899 units, but we're going to keep it at 900 since we're dealing with a continuous distribution. So every time you're dealing with a normal distribution, just keep that in mind. So that's for problem number one. Problem number two is saying, what is the probability that the demand will exceed 700? So we're looking at the right side of the distribution because we're exceeding here. So the right side is going to be all of this area that I'm trying to highlight. So what is that in terms of probability? Well, that's a range of probabilities because we're looking from 700 all the way towards the right-hand side. So I could apply the complement rule. Say 1 minus the sum of the complement. So let me go ahead and do that. So I'll hit 1 equal sign 1 minus norm.dist, select x, or enter x. In my case, it's going to be 700 still. Mean is 750. Standard deviation is 100. And I'll enter true. And this would be my probability. The probability that the demand will exceed more than 700 units is about 69.14%. Now, this last one that we have, number three, says, what is the probability that the demand will be between 700 units and 900 units? So we're dealing with 700 units and 900 units. And if we draw vertical lines on this curve, and I'll highlight the area that we're interested in red. So all of this right here. What is that probability? We're trying to figure that out. Now, what I need to do is use the norm.dist function twice within one cell. I'm going to look for the cumulative probability of 900. So from this line and everything to the left of the distribution. And then I'll do the same thing for 700 and everything to the left of that distribution. And that will give me my probability, but I'll have to make sure that I subtract those values from each other. So let me demonstrate. I will say norm.dist, select 900, the mean is 750, standard deviation is 100, and I'm going to say true. Right? So I'm going to subtract that from another norm.dist, but this time I'm going to put 700 and fill in the rest of these values. So this is what I would want to put in my cell to calculate the probability for a between this unit and that unit. So when I hit enter, 62.46% probability. So the probability that the demand will be between 700 and 900 units is this. Now, what did we do here? What I ended up doing is I first looked for the cumulative probability for 900. So I looked for everything from this 900 value and everything to the left of it in the distribution that we have right here. And then what I did is I did the same thing, but now I looked for everything from 700 and to the left. So I looked for that cumulative distribution. And what I did is I subtracted those two cumulative distributions from each other to get that probability. So I had to account for that overlap. So one other way I could have done this is by doing the norm.dist function twice in two separate cells. And then I'll do the same thing. I'll get this norm.dist, but this time I'll put 700 units. I have two probabilities, one for 900 and one for 700. These are cumulative, right? So here is a 900 and to the left. Here's a 700 and to the left. Now, if I were to subtract those two probabilities from each other, I get the probability, same probability that I got here. Now, let's go ahead and talk about the z-scores related to this problem. So I did create a probability distribution and created a visual so I could demonstrate some of this. Now, what I'll do is that probability distribution that I created, I'm going to go ahead and delete those probabilities, and I'm going to put z values here. And let's assume that we're still dealing with the same mean and the same standard deviation, where the mean is 750, standard deviation is 100. And I want to get the z-scores for each one of these values. So let me say this. So I'll do standardize, select that first value, subtract it from 750, divide it by the standard deviation. So that's what's going on with the standardized function. So I get a negative 3.5. Now remember, our values start at 450, so that's why we got a negative 3.5. Remember, anything that exceeds 3 absolute value, then it's an outlier. But we know that my beginning point is actually at 450 when I use the empirical rule. Now, here's another one that would be considered an outlier. Before I do the chart, what I want to do is create the probability for this series of values that I have here, these z values. So if I say norm.s.dist is different from norm.dist. So the .s means standardized values, and we have these values standardized since we have the z values here. So the z-score is this, and I do want to get a cumulative probability. Better yet, I'll just do false, and I'm going to get the probability for everything here. So all of these z values. And now I'll select the z-scores along with their probabilities, create a chart off of it. And we have something that looks like this. And I will go ahead and I'll select this one. And these are the probabilities. These are z values slash probabilities. This is the chart that I created before I standardized the values. And this is what was generated when I did standardize the values. So when you're dealing with a normal distribution, you have a family of distribution curves based off of the value of the mean and the standard deviation. So you could have a wider peak, have it flatter. Um, you could have the curve shifted to the left or to the right, depending on where the mean is. But for a standardized or a standard normal distribution, it's going to look the same regardless of the normal distribution that you're dealing with, regardless of the scenario that you're dealing with. And it looks like this. It's symmetrical, pretty clean type of bell-shaped curve. So here towards the center, we have the value 0. And this represents the mean of whatever you're dealing with. Dealing with the normal distribution, the center is 750 in the scenario that we are working with. So sometimes you might be working with z values rather than actual data values. So if you have a probability that looks something like this, where it says, what is the probability of z is greater than 2.5, or let's say less than 1.5, something like this. Well, then that means if 1 point, and this is a positive, so we know 1.5 is right here. Let me get the drawing feature out. Here's 1.5. Imagine this is a straight line, anything to the left of it, right? So we know that our answer is going to be more than 50%, again, because this is symmetrical. If I draw a line right down in the middle, I know this is 50% and this is 50%. So I could say NORM.S.DIST, the z-score output 1.5, hit true, and this would be my probability. So each value that we are trying to get a probability on, so if we, for example, problem number 1, what is the probability that the demand will be at most 900 units? Well, what is a z-score of 900 units? So if you look right here, the z-score of 900 units is 1.5 z-score, which we ended up getting the probability here using the NORM.S.DIST. So every normal distribution can be converted to a standard normal distribution to look for the probabilities. I'm going to go ahead and conclude here. Thank you for watching.